Hi, welcome to another edition of Moment of Science. I'm Cameron Sahami, and
I'm Kachin.
And we have a special guest with us today, Carter Emmart, who was here last week discussing a trip to Mars. This time we're going to be talking about colonizing and terraforming Mars. So Kachin, if you could introduce Carter to us again.
Yes. Welcome back, Carter. And well, Carter got his geophysics degree at the University of Colorado, and he was one of the original founding members of the Mars Underground, which was an organization that started the Case for Mars conferences. And Carter was one of the editors for Strategies for Mars, which was more or less a textbook on how to go to Mars and what technologies we need to develop to go to Mars. And in the two previous weeks, Carter talked about just what is involved in going to Mars. And now for today, we're going to go on and talk about permanently settling the planet and possibly terraforming it. So welcome again, Carter.
Welcome.
Thank you.
So, terraforming just sounds like such an immense task. I mean, where would people begin?
Well, I think it's important to point out that what terraforming is. I'm sure that probably a lot of people don't know necessarily what terraforming is. There was a movie a few years back called Total Recall, starring Arnold Schwarzenegger, and it dealt with a science fiction story in the future where Arnold was trying to get himself to Mars, and Mars was about to be engineered through massive engineering. People, colonists already there, turn it into an Earth-like world. And that's what terraforming is. It's a notion which came out of essentially Percival Lowell's observations of Mars and believing that he saw the signs of a dying civilization on Mars that had engineered the planet essentially to bring water from the frozen poles to the desert equatorial regions. That this was picked up within science fiction, and the word terraforming came out. It's terra, earth, forming, engineering. So it's planetary engineering to make a more Earth-like world. And in the case of Mars, looking at that to actually create another planet that could sustain life of all sorts in another biosphere, essentially, a full planetary biosphere on Mars, which some consider may be the real reason for the space program. The space program, we go, we explore, and we see, and we have the adventure of going and walking perhaps on other worlds like we did on the moon. But what is the ultimate utility of it? And some believe that that could be the ultimate goal of the space, of our activities in space. What are we doing here? So.
Well, the first step would be colonizing. I understand you're going to talk a little bit about that aspect of perhaps colonizing Mars first before you implement sort of a planetary change.
Well, it's a matter of progression, and the artwork that I showed last week ended with a slide of a city on Mars. And although we only went to the moon in 6 missions and 12 American men walked on the moon, there were plans to continue our exploration of the moon and put bases there, just as our first steps into space were into Earth orbit, and eventually we had space stations like we have there today. And so the notion is one of first exploring, first steps on another world, then setting up scientific outposts, and then possibly cities. And once you have a city, you're really going the direction of colonies. You're growing your own food. You're sustaining your own resources. And it's just like the colonization of the New World here in the U.S., was that people came over and they were to some degree dependent on certain resources and in exchange with the Old World. But then eventually people were self-sustaining here and didn't want to suffer the rules and so forth imparted by the Old World across the ocean. And so we had a revolution here. And then the Western expansion, people pushed out and displaced the people that were already here. Mars, as far as we know, doesn't have any indigenous people. It may have indigenous bacteria, but and that's quite fascinating question. In fact, Mars, the whole issue of life is really what Mars is all about. It's, we want to go and see whether we have neighbors. And that has a grand implication as to the starry sky we look at every night. Is it populated, or are we a unique entity in the universe?
Great. Well, I understand you have some slides. Let's go ahead and get to those.
I'll start off with a couple slides, and I have some video
Oh, great.
of what that'll be. Once again, I showed this slide 2 weeks ago. This is a drawing by Percival Lowell, and at the turn of the 20th century, Percival Lowell had established an observatory in Flagstaff, Arizona, to observe Mars with a telescope that he built, but he really wasn't a scientist. And he observed these, what he thought were canals on Mars. The Italian observer Schiaparelli had reported seeing canali, which mean channels if you directly translate it into English, but it was widely considered canali as translation as canals, which connotes engineering. And so Lowell looked at the features and believed that he saw through the scintillating Earth atmosphere, kind of like looking down railroad tracks on a hot day. You see this waviness in the air, and if you look through a telescope, that's what Mars looks like. You can't see distinct features like you see in this drawing. But what we see here are these major features that we do see, and we still see today with spacecraft. Here's Syrtis Major, which is the most dark feature on Mars. And here's the south polar cap and the north polar hood over here. We see these features, they're real. But the finer detail, these canals, are what Percival Lowell thought he saw. And so these are the canals of Mars, which Percival really did believe he saw, and he considered that these were canals to bring water, melted water from the polar caps down to the desert equatorial regions of Mars. And seasonally, he would see features change and consider that to be seasonal variation of these fields and so forth being greened, just as we do in California's Central Valley and the San Joaquin, green those fields by the use of irrigation. So if we go to the next picture, here we see Antionetti's painting from 1909, and this was a very skilled observer doing watercolors of what he saw on Mars. And there are features that are somewhat linear, but they're not canals. They're not these canals that Lowell saw. But there was a whole lore of Mars that was built up on the notion that there might be Martians engineering their world to save it from destruction because it was drying out. So if we go to the next slide, here we see the notion of Mars changed in the future. Here's the notion of not Martians engineering Mars, but humans going. And Arthur C. Clarke's book, The Snows of Olympus, the cover shows a painting by David Hardy, a British space artist, showing here's the large canyon on Mars, Valles Marineris, filled with lakes and water, and the type of cloud systems that one would expect associated with an equilibrium state with water. These are cumulus type clouds and so forth, associated with water that's evaporating directly off the surface, off a wet surface of Mars. Mars has too low of an atmospheric pressure today to sustain water, and but here we see the notion of people engineering Mars. And I think we ought to go, let's go to the next slide. And this is what Mars looks like today. And this is a computer rendition of Mars that I worked on, which has a map from the U.S. Geological Survey based on the Viking missions in the 70s. And we see a large volcano over here, Olympus Mons, other volcanoes, and this large canyon system, Valles Marineris. And we see these features that Lowell had seen. But we see the color, the orangey red of Mars is the color of desert, and indeed it is. It's a cold, frozen desert with a thin atmosphere. But we can see in some of these features, these flowing features, that indeed, although Lowell wasn't correct, there were channels on Mars. The spacecraft saw channels on Mars, and those channels on Mars could probably only be formed by liquid flowing, running liquid water on Mars. And that indicates that in the past, Mars was once much warmer and had a thicker atmosphere and allowed for running water. And so with that, I'd like to sit down, turn the lights on again, and we can go to some video. I'll come back to the slides in a little bit.
Okay.
But the notion of having liquid water on Mars and liquid water on Earth begs the idea of, if you've got liquid water on both worlds, could you have had life evolve? And so we now have the Martian meteorite that seems to have possible life traces and so forth. So this question, could life have arisen, is very interesting, because that rock dates back to a period when there was the beginnings of life on Earth. And so we have the origin of life on Earth, and at that same period we can look at the record of these channels and carved features on Mars with water, and we can see that there was running water at that time. And then we get this meteorite that seems to be dated from about that period and has signatures that seem to indicate life. It's not definitive at this point, it's still being argued, but it's quite interesting. So this notion of Mars being warm and wet in the past, what happened to it? Right around the time that the planets were ending their sweep of debris, the late bombardment phase, which is the moon is pockmarked with all these craters, but a lot of that crater terrain dates back to about 3.5 billion years ago, that we see Mars has these signatures of flowing water. And so what happened to the atmosphere that would have allowed, that thick atmosphere that would have allowed water to exist in a liquid state, and what happened to all that water? Because we don't have that on Mars now. And if you look at geochemical processes and things like this, you can see that if you have silicate rocks and you have a carbon dioxide atmosphere and the presence of liquid water, the three combine and they make carbonate rock. And carbon dioxide essentially gets sponged by the rocks and solidified into carbonate rock. And then the water can get frozen into ice. And you have, Mars has craters just like the moon. It was busted up by all sorts of debris falling in. And that water falls down into the space between the rocks and forms as permafrost. And then the atmosphere is lost over time with planetary impacts and loss to interaction with the solar wind and so forth. Mars doesn't have the magnetic field. It's a smaller body than the Earth. It's sort of midway between the moon and the Earth. And so here you have the smaller body, and it started off like Earth, it seems like, but then it stopped. Well, what does that mean for the future? If we run the video.
So the real question is how to liberate this water? Is that
the real
basically what it
question
boils down
is,
to?
if we've got this past on Mars, and that we've got the atmosphere that used to contain the water is still there in the rocks, could we run the clock backwards? And how would we do that? So if we can run
Let's
the
go
video,
ahead and roll that video.
I can
believe
talk
this
over
was
it.
This was video prepared by NASA, correct?
We prepared this for NASA, Complex Systems Research in Niwot, Colorado. We did this on the computer for NASA Ames Research Center, Chris McKay out there. And here we see Mars rotating as we see it today. And as we complete one revolution, we start to fade up an ocean, a blue ocean. And this is the -2 kilometer. The contour level is somewhat arbitrary, but that's -2 kilometers. We see the sun glint off one of the little lakes there. And you can also note that through this animation, you'll see the atmosphere get a little thicker and bluer. And we've erased the clouds here for the clarity down to the surface. But a later animation shows what those clouds would be like. So here we see another level of ocean, the -1 kilometer, fading up. And we can see we're just backfilling in topographically. We're using the topography map to indicate where the shorelines would be, and so forth. But this is what Mars would look like if it had oceans to that -1 kilometer level.
Now, is there an estimate of the amount of water? Because I imagine the original 2-kilometer contours is now 2 kilometers deep at this point, right?
That's correct. It's not anybody's guess, but as some scientists, Bruce Jakosky here at the university, I've been calling him and asking him what's a good level. He said, well, pick a number. But this is about the maximum extent here, which is conjectured if you could liberate all frozen water molecules there on Mars. If we let that run, if we let the video keep running, here we see an animation of the flood. We're looking at Sinus Meridiani there, and we have we have the ocean just filling in. And there's several videos. Keep them running here. I can just keep talking over them. So this one shows what an animated version of that flood would look like, filling in.
See the recession of the
That's
cap a little bit?
Tharsis that we see, where the volcanoes, the large volcanoes on Mars are just below. And Mars continues to rotate, and we see the area around Elysium, which is also a volcanic area. We see that island of Elysium, where the face is, getting flooded there.
So like the island of Atlantis.
Exactly. And so again, we see Mars getting a thicker and bluer atmosphere, and the water filling in.
Now, are you able to liberate enough atmosphere from the ground to keep the water on Mars?
Well, that's the notion the scheme by which you would do this are various schemes. What you would have to do is to liberate that carbonate, to liberate the carbon dioxide that's frozen in the carbonate rocks, and then allow the melting of the water. Here we'll see the flood. I'll get to the scheme in just a second. We see the flood and build up, atmosphere turning blue. It comes to a stop, and that's vegetation fading up.
Wow.
And then if you add the clouds, that's what the end result would look like. Almost identical to Earth. It's hard to tell. The clouds dominate, and you'd have about 50% cloud cover, but that's what you would have in the case of an ocean-covered world where you have the oceans in equilibrium with the atmosphere. We can cut the video now, and we can just go back to talking about this a bit. So what you would have to do to liberate the water and liberate the carbon dioxide is add energy to the surface. And there are various schemes for doing that. And some are more horrific than others. But you're talking about a planet-wide scale of having to impart energy into this carbonate to liberate the carbon dioxide from the rock. You have to vaporize that off the rock. And once that atmosphere gets to a certain thickness, it allows, with the greenhouse effect, to warm up Mars. And the temperature gets high enough to where the water that's frozen in the permafrost melts and comes out into equilibrium with the atmosphere, and you get clouds, and it percolates and it condenses out and collects in the lower basins as the flood, which you just saw, which would be the water. That's the mechanical part. Then you have an atmosphere of carbon dioxide. You want to turn that into oxygen to shield the ultraviolet and so forth, and that would require a process, ecopoiesis, which is the imparting of a biologic system to change the carbon dioxide to oxygen. So the method by which you would do this, one method is to concentrate the sun's energy with big space mirrors and warm up the planet. But a perhaps faster method is the use of condensed energy sources like nuclear bombs. And in order to do that, papers have been written that look at the amount of energy you would need to actually liberate the supposed carbonate rocks that are there on Mars. And we don't know that inventory. So the calculation is a rough estimate. But at Complex Systems Research, we created a commercial of what it would be like to look at a terraforming company's feel-good commercial in the future about using nuclear devices to liberate the atmosphere from the rocks, vaporize those rocks, also vaporize the permafrost at the same time, and essentially give you a Mars very quickly that would have the atmosphere and the water similar to Earth.
Did you bring that video? Is that right?
Yes, and so if we could roll that video, it
roll that.
shows what that would look like.
Hey, what about Major Kong?
Well, I'm not sure that was it.
This is the wrong video. This is not the message that we want to show. I'm sorry.
That's a slightly different message.
Well, it's definitely related.
But if we roll the next video, I hope that's the correct one.
And can you just tell us what exactly are we about to see? Well, actually, here we go.
Is the audio up?
Mr. LeMay, we are ready with the revised promo.
Good. I've got to run back and put out a brush fire my nuclear engineers got into.
Understood, sir.
Can we
This
roll
spot
it back?
increases the emphasis on your new Earth-like
let's have
Well,
Okay. Here's a setup.
Mr. LeMay, we are ready with the revised promo.
Good. I've got to run back and put out a brush fire my nuclear engineers got into.
Understood, sir. This spot increases the emphasis on your new Earth-like Mars.
Mars, frozen and desolate, awaiting a bold vision of creation. Our planetary engineers will terraform Mars, rebuild it, make it better. We have the technology. Imagine the new Mars, because at Planetdyne, we create worlds.
Well, sir, what do you think?
Certainly interesting. Those were each little nuclear explosions going off, right?
Those were each, a city buster typical developed hydrogen bomb out of the Cold War was about a yield of 1 megaton or 1 million tons of TNT. I believe the bomb that hit Hiroshima was 20 kilotons or so. I may be wrong about that. But each bomb that you see there, properly scaled, properly visualized. Starley on our team is an atmospheric scientist up at NCAR, but here at Complex Systems for this little commercial, properly calculated out the bombs there, which would be of a yield of 1 gigaton each. That's 1 billion tons of TNT. These are fusion bombs and with a tritium. Tritium is a byproduct, radioactive tritium, with a half-life of about 12 and a half years. So in about 100 years or so, it's safe to move in. It's safe to move the troops in. But the bombs you see there were about 1,000 bombs going off in that one little commercial spot. And it says actually up at the top, it says swath 1 out of 2,800 swaths. So you essentially need about 2.8 million or almost 3 million 1 gigaton bombs to do this. So essentially what you'd have to do is move into Mars and set up a factory to do that.
And make the bombs there.
That's right. And you also see the facade of NCAR in there, and that's where I work at my other job. It was meant to be as a joke for the future, and you can see that that's a setup. It's an advertising company. It's Grand Fromage Advertising Agency in the year 2047.
Big cheese.
Yeah, after the scientists have moved out.
Now, are there any other scenarios? I've heard a talk of scenarios where, say, they sprinkle soot across the polar caps, and that significantly lowers the albedo, more insulation, that
Carl
type of thing.
Sagan was one of the first people to actually look at this. When Mariner 9 visited Mars in 1971, we began to have a better understanding of Mars, and Carl was looking at forms of planetary engineering and conjecturing about this for the future. And methods of sprinkling soot or diverting asteroids to collide with and impart energy into the surface. You might melt a lot of what's there on your impact site, but you're also going to blast a lot of atmosphere off of Mars. So these schemes are all quite outlandish, but the very notion that they're within the realm of conjecture and calculation probably mean that the ultimate goal, as I started out saying, would be one where if we could create another biosphere and another abode for life, again, we had to bomb Mars in this commercial to make it better. Essentially, out of that scenario is a plausible calculation that could create another world and another abode for life. And a lot of people would say, well, we're screwing up this one, why do we want to go screw up another? But the notion is we're always going to have to manage Earth. Earth is our home. We have to cherish it. We have to take care of this first and foremost, regardless. But I also believe in going out into space to access those resources. And if you can turn Mars into another abode for life, if it doesn't have an indigenous abode of life, then people will probably do it one day.
Yeah, that does bring up a moral or ethical question. What if we do discover that there are still microbes living on Mars today?
Well, we have to figure out whether they were Earth microbes, because we now know that these rocks, we've got about a dozen or so rocks that we believe are Martian rocks. Then could indeed our life have seeded Mars life? And so that really gets to the heart of the origins of life question, and that is a fundamental question, but it is a fundamental moralistic question, and there's so many of them regarding so many areas here on Earth of whether we should be strip mining, whether we should be cutting forests down, and so forth. A lot of those questions. I think once we have this capability to do this on Mars, we'll pretty much have hopefully better moral answers from our own terraforming of Earth.
Yeah, I think if it's just prehistoric microbes, just screw them.
How many do you kill every time you wash your hands?
Yeah, that's right.
Yeah.
Well, that was fascinating. I want to thank our guest, Carter Emmart, for being here. It was an excellent program.
Yeah.
And if you'd like to learn more about this topic, check out our webpage. The address will be in the credits, and there'll be links to Carter's page and other related pages. And I want to thank everyone for joining us this week on Moment of Science. Thanks.
Have a good night.
Thank you.